Alright, so Algebra 2. We've got a section on graphing systems of inequalities, section 3.3. Pretty much what we're doing is graphing two half planes, or in the case of the absolute value inequality, of V that's been shaded. Remember, these things are shaded, and now we're not just talking about a single point where these two lines cross. We're talking about a whole bunch of points where they cross. So we will be shading the area that they have in common. So the solution here will have many points. So that's why we'll shade. Now, to graph this thing, we might have to use our x and y intercepts. That's one possibility, right? My y-intercept here is 6 divided by negative 2. It's almost like I ignore the sign and treat it like it was an equal sign. I know that that's not how I'm going to graph it in a minute, but I'm going to treat it that way just for a moment. So 6 divided by negative 2 is negative 3. When you plug 0 in for y to find the x-intercept, of course you find out that it's 6. All right, I'm covering those up because they become 0. So on my graph, I have 0, negative 3, and 6, 0. Now, I'm not going to graph a solid line. Because this is not equal to, I'm going to draw the dashed line. And we need to know which side of the line to shade. I told you to pick a point, not on the line, such as 0, 0, and plug it in. Since 0, 0 is not on my line, I can use that one. When I plug in a 0 for x and a 0 for y, I get 0 is less than 6. Is that a true statement? The answer is yes. So just for now, I'm going to draw a small, tiny little arrow indicating which side of the line I'm going to shade on. Now the reason I'm doing that is so that we don't get confused about, once I have a couple of these on the graph, you'll understand why. For a second, I don't want it to get really messy. And it might be hard for you to understand what are the true solutions. So now I'm going to graph the other one. Plus 5, so up 1, 2, 3, 4, 5. It's got a y-intercept of 5. And a slope of negative 3 halves, so that's down 3 and 2 to the right. And down 3 and 2 to the right. This one has an equal to, so it's going to be a solid line. And I remember I told you that your gut instincts when it's solved for y are always right. When you say less than, you want to shade below the line. Okay? In this case, that would be below the line this way. But if you're in doubt, pick a point not on the line like 0, 0, throw it in. 0 is less than or equal to, 0 cancels this term out, so let's say 0 is less than 5, which is also true. Now you notice where both of these little tiny arrows have come together. So if you shaded everything from this line down and everything from this line up, they would overlap in an area out here. There are millions and trillions of points out in this shaded area. And that's where all my solutions are. Every point that sits out there would be a solution point to both inequalities. The first 3 questions in the homework that we'll look at tomorrow in class are doing that kind of same thing. Okay? Let's graph something like this. We know that y is less than 4. That's a pretty easy one. That's a horizontal boundary line. 0 is the slope. 1, 2, 3, 4. It's a dashed line. Y less than that would be shading below. Now, y greater than, the absolute value inequality is back. That's 3 units to the right. 1, 2, 3. There's your vertex. Slopes are 1 and negative 1. Please make sure that you're using slopes of 1 and negative 1 and don't make them, other than that, Don't be sloppy when you draw them. You want to do 1 and -1. Okay? And it's got the equal to, so I know that's going to be a solid V. It says greater than. When we know that it's y is greater than, we know that we're shading above. And that fits my common sense. So I'm going to go ahead and shade above. But if I want to test it, I can always pick a point not on the boundary lines, which 0, 0 is not on the boundary. Plug it in. 0 minus 3. Take its absolute value. That would be 3. 0 is bigger than 3. I don't think so. So I'm shading above or inside. Now, let's think about this. If you're shading inside of the V but below the dashed line, then that overlapping area is this triangle area right here. Well, we could have areas outside here and here. We could have inside the V and above the line. We could have below the line and outside the V. There's all kinds of different shapes we could come up with, depending on what the inequalities look like. Okay, I got a few of them for you to do. Okay, here's your first one. So I want you to graph those two and find the shaded region. Okay, we'll talk about that one in class tomorrow, but I want you to try it on your own. Don't just give up on me. Try it on your own. Same thing with this one. Here, I want you to try this one on your own, and we'll see how you do. At least get the boundaries down. If you don't understand the shading part, then we'll talk about that in class. And the last one I want you to do on your own is page 132, number 17. Those 3 questions you need to work on your own and bring to class tomorrow. See you tomorrow.